Hello everyone, welcome to all in this video lecture series of Database Management System. I am Deepak Aneja, Assistant Professor, ABS Engineering College, Ghaziabad. Today in this video lecture, we will cover the topic Dependency Preserving Decomposition. We have already studied about the decomposition. As per father of DBMS, decomposition should be lossless decomposition, and second is dependency preserving decomposition. So in this video, we will understand the concept of what is this dependency preserving decomposition. Dependency preserving decomposition is if a relation R is decomposed into relations R1 and R2, then all the functional dependencies of R either must be a part of R1 or R2 or must be derivable from the combination of both relations FDs. So definition, a decomposition D is R1, R2, R3 and Rn of R is dependency preserving with respect to a set of F of functional dependencies if F1 union F2 union up to Fn, the closure set of all union of all functional dependencies that must be equals to the closure set of original functional dependency. So let us understand this concept with an example. So here is example. Let a relation R, attributes are A, B, C, D, and functional dependency set F equals to A, B determine C, and C determine D, and D determine A. Relation R is decomposed into R1, attributes are A, B, C, and R2, C, D. So R is a relation, attributes are A, B, C, D, that will decompose into R1, that is A, B, C, and R2, C, D. First of all, we have to check when R1 union R2, that must be equals to R. So combination of A, B, C, C, D. So A, B, C, D, we can get all the attributes present in the relation R. And second, R1 intersection R2 does not equals to phi. There must be some common attribute. Here the common attribute is C. Now we will check the whether this decomposition is dependency preserving or not. Now, here is R1, A, B, C, or here is R2 relation, C, D. Now, write the possible non-trivial functional dependency of the attributes of R1. So attributes are A, B, C. So possible non-trivial functional dependencies: A determine BC, B determine AC, C determine AB. The next combination is AB determine C, AC determine B, and BC determine A. There will be no other possibility of any functional dependency to create any functional dependency. These are all the possible functional dependency. Now we have to take the attribute closure from attribute closure of left hand side from the original functional dependencies that the R relation R holds. So these are the functional dependencies. Now take the attribute closure from the original functional dependency. Now from A, we can determine A, then we cannot determine anything else. So here we can see that it cannot determine this BC. A cannot determine BC. So this dependency cannot hold. Now take the attribute closure of B from original functional dependency. From B, we can determine B, and from B, we cannot determine anything else. So can't determine. So this functional dependencies cannot hold. Now take the closure set of C. From C, C to D, D to A. Now A, from A, we cannot determine anything else. Now from C to AB, we can't determine. So this functional dependency also cannot hold. Now take the attribute closure of AB. Now AB can determine, from AB we can determine C, and from C we can determine D, and D to A. So AB can determine C. From AB we can determine C. So it can determine. So this functional dependency will hold. Now take the attribute closure of AC. AC from C to D, and from D to A. So from AC, B cannot determine. Can't determine. So this can't hold. Now from BC, take the attribute closure of BC. BC from C to D, and D to A. So it will hold. BC will. So can determine. So this functional dependency also hold. Now, similar case with R2 relation. So here the possible functional dependency is C to D and D to C. Sorry, D to C. C to D and D to C. Now take the attribute closure of C from the original functional dependencies. From C, we can determine C. From C to D, D to A. So from C to D, we can determine. Can determine. So here, take the attribute closure of D. D from D, D to A. From A, we cannot determine. So it cannot hold. So this will hold. Now take the possible functional dependency set. Now the union of all possible functional dependencies. So here is AB determines C, BC determine A, and C determine D. So this is the possible set. Now here we will write possible functional dependency set. Set is AB determines C, BC determine A, and C determine D. Now take the original functional dependency set. That is AB determines C, C determine D, and D determine A. Now check the original FDs from possible FD set. Now A, B, and C as it is hold. Now take the attribute closure of C from possible functional dependency set. Now take the attribute closure of original functional dependencies from the possible functional dependency set. Now we can determine C to C and C to D, C to D and nothing else. So we can determine C to D. Can determine. Now same check for D attribute closure of D from possible functional dependencies G to D, and we cannot determine further. So it cannot determine A. So it cannot hold. So we can say that if any of the functional dependency set cannot determine from the possible functional dependency set, so we can say that the given decomposition is not dependency preserving decomposition. So the calculated functional dependencies cannot hold the original functional dependencies. So this is not a dependency preserving decomposition. I hope you will understand this concept. Now let us take one more example. Let a relation R, A, B, C, D and functional dependency set F equals to A determine B, B determines C, C determines D and D determines B. Relation R is decomposed into R1, R2 and R3. So here is R1 is AB, R2 is BC and R3 is BD. Now take the possible functional dependency set. Non-trivial functional dependency set. From AB, we can determine A to B and B to A. Now take the attribute closure from the original functional dependency. A to A to B, B to C, C to D, and D to B. So we can determine A to B. Can determine. So it will hold. Now take the attribute closure of B. B to B, B to C, C to D. We cannot determine A. So we can't. Now here in R2, the possible non-trivial functional dependency set is B to C and C to B. Take the attribute closure B, B to C, C to D, D to B. So here we can can determine. Hold. Now take the C, C to D, D to B. So we can determine B. So can determine. Will also hold. Now from R3, here is B to D and D to B. Take the attribute closure of B, B to B, B to C, and C to D, D to B. So we can determine D can determine. So it will also hold. Now take the attribute closure of D, D, D to B, and B to C, and C to D. So we can determine D to B. Now take the union for possible FDs. So possible FDs are A to B, B to C, C to B, B to D, and D to B, B to D, and D to B. Now take the original functional dependency set R A determine B, B determine C, C determine D, and D determine B. So both are same, both are same, and both are same. Now check for this. Now take the attribute closure of original functional dependencies from the possible functional dependencies. So we can determine C, C to B, B to D. So here C to D we can determine. So it can hold. So we can say that the decomposition dependency preserving decomposition. I hope you will understand this concept. References. Thanks for watching this video.